Hey guys, in case you didn't do your homework for Chapter 2, I'm going to show you how to do Chapter 2.1 and 2.2 homework. And you should be able to complete this homework by Friday and turn it in before the end of the quarter. These are relations and functions. We discussed this in class. And so there's 3 ways to do this, and we'll teach you all 3 ways in this little exercise right here. A motion detector tracks an egg as it drops from 10 feet above the ground. The table shows the height at various times. So here it is. The time is 0. It's dropped at 10 feet. And these are tenths of a second, so you can see how it goes down. So this is the table. We also have to represent the data by using a mapping diagram, ordered pairs, and a coordinate plane. So I'm going to show you all 3 of those. First, let's do ordered pairs to get that out of the way. So the first one is 0 to 10. So we're going to map that, or ordered pair is 0 to 10. Second one is 0.1, 9.8. And so on. 0.2, 9.4, 0.3, 8.6, and 0.4, 7.4. So we have the ordered pairs finished. 100%. Now we need to go to the mapping diagram. If you remember a mapping diagram, you have the domain on one side, which is the x values. On the other side, you have the range, which is the y values. And all it is these little bubble guys. And you draw arrows connecting the x's and the y's. And this is pretty redundant, because you know over here it looks exactly the same. 0.1 goes with 9.8. 0.2 goes with 9.4. 0.3 goes with 8.6. And 0.4 of a second goes with 7.4. So far we have done and seen a table, ordered pairs, and a mapping diagram. The third one here is a graph on the coordinate plane. So you're just going to graph it. And you just want to draw the y-axis and the x-axis. Here's the y, here's the x, right? And then you're going to do pretty easy. The feet is 10 is the max, and the 0.4 is a second, right? So what you want to do is go 10 up here, maybe do 5 here. This could be 7.5 if you want it to be, and half of that is 2.5. From here you can go all the way to 0.4. So you probably want to do 0.5 actually, just to make it a better number. And then you can do 4 little things here: 0.4, 0.3, 0.2, 0.1. Then you're just gonna graph all these. So 0 is at 10. 0.1 is 9.8. 0.2 is 9.4. 0.3 is 8.6. 0.4, I'm sorry, is 7.4. And that has the biggest drop off right there, right below that. So you see it right there. So there's a line of best fit. What are the domain and range of this function? I think we just put them up here. Here's the domains, here's the ranges. So we just have to recopy that down. Domain is 0, 0.1, 0.2, 0.3, 0.4. The ranges are right here. All the x. 9.8, 9.4, 8.6, and 7.4. Any questions? All right. Determine whether each relation is a function. And this one you couldn't see. This whole idea over here was not for you. So I apologize. This is supposed to be 1, 2, 3, 4, 5. And the ranges are supposed to be -1, 5, 3, 6, and 0. And the arrows are all wackadoodle. So I'll try to draw this for you real quick. The 3 goes with the -1. The 1 goes with the 3. The 4 goes with the 0. And the 5 goes with the 6. And so this is a function because nothing is repeated. And this is a function because nothing is repeated. See, nothing is repeated. All right, use a vertical line test. These should be easy. Remember the vertical line test, if you draw your pencil or bring your pencil across the graph, it should only hit the graph at one place. If it's at two places, it is not a function. And it does only hit at one place. So this is a function, yes. And this is one of the easiest tests you'll do in math and questions you have. See, 1, 1, 1, 1, 1, one place the entire time. So 5 and 6 are yes, and 3 and 4 are functions too. Those are yes. Number 7, vertical line test. And you can see, I might want to do with my tip right here. If I go like this, my pencil goes through the line on the graph twice. Once down here in the bottom and once right here in the top. So this would be no, it is not a function. See that? Not a function. All right. Number 8. And this is 2-1 homework still. We'll go to 2-2 after this. All right. Number 8. Evaluate each function for the given value of x. So you're just going to plug these in. So when it says evaluate, which means solve, and the given value means plug, you're just going to plug them in. So x is 3. So I'm going to rewrite this by plugging in 3 for the x. So 4 times 3 is 12. 12 plus 1 is 13. So the function of x equals 13. Not that bad. This is x is 5. So 2 times 5 minus 11. 2 times 5 is 10 minus 11, right? 10 minus 11 is actually negative 1. And let's get in the habit of circling our answers too. You want to make sure you do that. Number 10 is a little more tricky. 6 times 3 plus 3 divided by 7. So we got to solve the top before we divide. So 6 times 3 is 18. 18 plus 3 is 21. 21 divided by 7 is 3. Number 11. X is 4. So you have 5 over 2 times 4. So you can rewrite this. I'm going to put this in parentheses to make it look a little nicer. Times 4. So a couple ways you can do this. I would do it by 4 times 5 is 20. 20 divided by 2 is 10. Correct? You can also rewrite it if you want to make it something a little different. Whenever you multiply fractions, sorry, I messed up that first part. You can do 4 over 1 and just do straight across. 20 divided by 2, right, equals 10. Again, they're getting a little more difficult. You might have to use your calculator for this one. 7 times 3/4 minus 1/4. So 7 times 3/4 does get tricky and gets into the realm of fraction land. So let's do this in our calculator. Do the whole thing in my calculator as we see it on the paper. 7 3/4, oops, right, minus 1 ABC4. You get the answer 5. Just make sure you circle that after you do all your work. Show your work. Be a good student. Show your work. Negative 2 times 6 plus 5. So inserting the 6 in for the x, you get negative 12 plus 5. And then that answer is negative 7. Okay, number 14. Write a function that produces an output of 7 for an input of 1.5. Answers may vary. An easy one you could do would be function of x equals 4x plus 1. So output of 7. So you put 1.5 in here times 4, right? 1.5 times 4 is 6. 6 plus 1 is 7. So that's an easy function to do that with. And how do I do that? Easiest way is take 7, right, and divide it by a number to make it smaller. So you divide it by 7 by 1.5 in your calculator, you get that crazy number. So if you take something off of that, 7 minus 1, you get 6. Then divide it by 1.5, you're like, oh, 4 is a great number I can use. So that's why we have plus 1 there, and then divided by 4. And so you plug it in and do it forwards, it's 4x plus 1. So you kind of use your brain inside out there, kind of like a car mechanic would do when fixing your car, or a guy fixing your heater in your house. They have to work backwards sometimes. Number 16, a cable company charges a monthly fee of $24.50 for cable service. There is an additional cost of $3 for each premium channel, which is most TV channels now. I think they're more like $6 or $7. George has a cable service with 4 premium channels. Write an evaluated function to find the monthly cost of George's cable service. So we're going to go f of x equals 3 times the channel plus your starting weight of $24.50. And that's kind of like your y-intercept. Then you have $3 per channel. We have no idea how many channels he's going to order. But then it tells you later that he does 4 channels. So we're going to put 4 in for that. 3 times 4 is 12 plus $24.50 equals $36.50. You can put the dollar sign. Number 16, Mr. Reynolds is a car salesman. He makes a salary of $55,000 a year. He also earns a commission of 1/12 of his total sales for the year. This year, Mr. Reynolds has a total of $295,000 in sales. Write an evaluated function to find Mr. Reynolds' total earnings for the year. Let's first make the function. The function of x equals x over 12. So whatever sales he has, you divide it by 12 to find how much money he makes on those sales. And that tells you that right here. And then we're going to add up plus his base salary of $55,000. $55,000 base salary is pretty good. A lot of people can survive on that without even selling a car. And now we find out later that we put in $295 in there. So $295, $200 is his car sales for the year. Divide that by 12 plus $55,000. You find out how much this guy actually makes. So let's put that in our calculator. $295, $200 divided by 12 equals $24,600. You plus then our $55,000. You get, nope, it meant to be $55,000 there. Oops. $55,000. You get $85,100 a year. So this guy makes a pretty good salary. Per year. Did I do that wrong? I think I did it wrong still. Let's find out. $295, $200 divided by 12 plus $55,000. Yeah, $79,600. I think when I put the wrong number in the first time, I never switched I think it was an extra 5 in there. Remember, everyone makes mistakes. You have to check your work sometimes. Kinetic energy is an object in motion, right? Einstein, science class. You guys have learned this before for a long time. So, the formula of K equals 1/2 mv squared is used to calculate kinetic energy. The variable m is the object's mass and v is its velocity. Calculate the kinetic energy of 45 milligrams object traveling at 3 meters per second. Your answers will be in joules. So your label is going to be in joules, which is pretty sweet. I think that's a guy's last name that does this. So we're going to put in our K. Rewrite the formula from up here. It's not too hard. The m right here is the object's mass, and v is its velocity. So there's this 45 kilogram object. The velocity we just learned was 3 meters per second. There's our formula. We just copied it down from here.